Is life but education is better. To all our students, sa lahat ng ating mga mag-aaral, make use of your time wisely and productively, because there is a saying that goes like this: the time is like a river. The part of the river that has passed will never be touched twice. And take note, treasure every moment of your life. Welcome once again to MaqLinz TV. Siyensya muna tayo ngayon dahil zero sa fishing. In my other video, we talk about free fall, how fast, and as a sort of recall or recap, free fall how fast can be determined using the equation V equals gt. Meaning to say, we can get the instantaneous speed of a free falling object by multiplying time by acceleration due to gravity. And take note, part of recall also, that the value of acceleration due to gravity is 10 meters per second, meaning to say there is an increase in speed of about 10 meters per second or 9.8 meters per second of fall. And every point of time, as I said, the speed of a free falling object increases, and so the distance. So today we will talk about free fall how far. Free fall how far can be determined using this very simple equation: d or distance equals 1/2 of g times the square of time. Now let us going to determine how much distance is covered by a free falling object per unit of time, because we have determined how fast that free falling object travels in a certain point of time. So d once again is equals to 1/2 gt squared. Okay, so you're going to get 1/2 of the value of acceleration due to gravity and then multiply it to the square of time. For example, if a free falling object falls after 1 second, what could be the distance covered of that by that object? So using the equation d equals 1/2 gt squared, let us just substitute the value of acceleration due to gravity to g, which is 10 meters per second squared, and then substitute also the value of time, which is 1 second, and then square 1 second. That will become 1 second squared. Okay, so based on the equation here, you have distance equals 1/2 gt squared. Let us substitute. You have 10 meters per second times 1 second squared. Okay, so you have 1/2 of 10, you have 5 meters per second. S times s is squared, times square of 1 is 1, square of s is s squared. So s squared over s squared is cancelled. So 5 meters times 1, you have a distance of 5 meters. After 1 second, the instantaneous velocity of a free falling object yesterday is 10 meters per second, while the distance covered is 5 meters. Now, what about after 2 seconds? Okay, so very simple. Again, you have to substitute the value 2 seconds to t squared here, and then you have 1/2 of 10, it's automatically 5 meters per second squared, times 2 seconds, 2 second squared, that is 4 seconds squared, then cancel second squared, you have 4 times 10, no, 4 times 5, then the distance covered by that free falling object after 2 seconds is 20 meters. So you can see the disparity or the difference, that as time passes by, the distance covered by a free falling object increases. After 1 second, it only covers a distance of 5 meters. After 2 seconds, it covers already a distance of 20 meters. Then after 3 seconds, it covers already a distance of 45 meters. Meaning to say, every point of time, there is a rapid increase in speed of a free falling object because of the action of gravity. And in every point of time, there is also a corresponding increase in distance covered. Now, sir, is there a chance that this increase in speed stops? The answer is yes. We have to talk about terminal speed or terminal velocity. Now, once terminal speed or terminal velocity is achieved, that free-falling object stops accelerating, meaning to say it will no longer increase its speed. In that case, the buoyant force and the drag force caused by air will already equals to the weight of the object or to the force of gravity, and in that case there is no more acceleration. For example, a skydiver, no, when a skydiver wanted to achieve a smaller terminal velocity, they can change orientation while in mid-air. No, the lowest maximum, the lowest terminal velocity achieved by a skydiver when it faces down. So probably it has an average of 120 miles per hour, while if the travels down, heads down or feet down, they can have a maximum terminal velocity of 160 miles per hour. Now, what's the use of a parachute used by these skydivers? Parachute is to cut the terminal velocity of skydivers, because if this terminal velocity are not cut or is not cut, then it would be very difficult for skydivers to control their downward motion. So again, no, free falling object can achieve this distance using the equation d equals 1/2 gt squared. So it's just very simple. 1/2 of g, that's 5 meters per second squared, and then multiply it to the time, and then you square first the time, including the unit, then cancel the unit of time, then you can have 5 times the product, 5 times the square of the time being substituted to your equation, and that would be the distance covered by a free falling object. Okay, so next time we'll talk about free fall, how long. Okay, so thank you once again for subscribing and watching my video. It's so hot in here, because I also have zero catch this morning. So as I said, let us treasure every moment of our life, because time is like a river. You cannot touch the same river twice, because the water that has passed will never pass again. Thank you and good morning.